I'm going to start the forum with introducing Dr. Mo Abuali, who is speaking in honor of the AI Andrew Memorial Lecture. Dr. Abuali is the CEO and managing partner of IoT Co., the Internet of Things company. He is a strategic and transformative technology and business management leader with a 20-year record of achievement, driving and sustaining change in manufacturing. The IoT Co platform offers seamless connectivity to any device and thing, intelligent cognition of data streams, and cross-IT system open collaboration to deliver results in digital transformation. Mo serves industrial and manufacturing clients in automotive, aerospace and defense, and others, providing digital transformation, industrial IoT, and predictive analytics technology and services, as well as the IoT Academy for Industry 4.0 training. Mo has a doctorate degree in industrial engineering and has worked with companies like IBM, P&G, Omron, and Toyota. Please join me in welcoming him today. Thank you again for your attendance, and we hope you enjoy the proceedings. Take care and stay well.
Yeah, Monica, thank you very much for the introduction, and hope you can hear me fine. Thank you, Stuart, for inviting me to the PEI forum. I appreciate the opportunity to speak to the colleagues here today. My topic is going to be around digital transformation with focus on manufacturing. So I'm going to talk about the industrial Internet of Things, and I will talk about the role of artificial intelligence and predictive analytics to support the digital transformation strategy of manufacturers. So thanks again for the invitation. A very small preface to the presentation, who we are as a company. IoT Co. is the Internet of Things company. We're based out of Cincinnati, Ohio, and we operate globally. Our DNA is manufacturing. We come from manufacturing and we serve manufacturers with the digital tools that they need to support their smart factory strategy, but also to support their smart connected product strategy in the field. So we operate with three practices. We support through education with the Academy, where we provide presentations like the one today, which is actually an excerpt of some of the training courses that we provide around Industry 4.0. And in addition to that, several digital solutions that not only apply to manufacturing, actually, but could apply to lab operations. It could apply to field operations of products. So that's who we are, a team of consultants and a team of data scientists. We call them industrial data scientists because they provide solutions to the industry. So I'm here today to talk about three things. And again, at any time during the presentation, please feel free to type in your questions, and we'll have at least 15 to 20 minutes at the end of the presentation today to answer your questions. So I want to first set the stage. There's a lot of jargon, there's a lot of acronyms being spoken. Folks talk about IoT, IIoT, Industry 4.0, AI, ML, so I can go on and on and on. So I would like to make some definitions of what those acronyms mean, okay, and how they relate to each other. And I would like to talk about the business case of why folks do Industry 4.0 and digital transformation today. And then I'm going to introduce what I call digital tools of the trade, okay? Those digital tools of the trade include connectivity, include metrics to assess your IoT initiative, and it also includes artificial intelligence and predictive analytics, and I'm going to focus more on that and give some case studies around the application of AI and machine learning in manufacturing. And I will give a summary, a simple 2 slides of how you can get started, and a call to action or maybe advice of how you could embark on that journey or how you can improve your existing journey, okay? So let's start with setting the stage. Internet of Things, right? If you look at the right side of the slide, the Internet of Things is by no means a new initiative. It might be a new naming, but it is by no means anything new. It's been around for decades. If you look at safety critical industries, the monitoring of jet engines as they fly in the skies, monitoring of power plants, especially nuclear power plants that are more safety critical, and the movement of connectivity using the internet, using the cloud into smart homes, residential usage of IoT devices like your Alexas at home. This is all about getting connected. It's about using the internet, and it's about delivering a certain business case and a certain service or value to the end user. Okay, so that's the Internet of Things. It encompasses all industries and all things and all devices. When we look at the left side of the screen, the industrial Internet of Things, IIoT, it is the application of IoT in the manufacturing or the industrial sector. Okay, so if you look at a factory today, you're looking at 4 layers as part of that pyramid. This pyramid was actually created as a standard by the ISA organization, the Standardization and Automation Organization, and it's called the ISA 95 pyramid. It starts with the machines, right? On the bottom layer of the pyramid, it starts with your the CNC machines, the programmable logic circuits, the PLCs, the sensor layer that is collecting data today from the factory floor. That's your machine layer. If you look at the second layer of the pyramid, SCADA, that's your supervisory control and data acquisition. Simply speaking, that is your data acquisition layer that is collecting the signals from those assets. And in many cases, there is data collection, and in other cases, there is no data collection on the factory floor. Okay, so we come to find that a lot of these layers are fragmented, they are siloed. There is still a lot of paper on factory floors. Paper is used by operators to write things manually. There's an ERP system at the top of that pyramid, your enterprise resource planning system, that sometimes is there, sometimes it's outdated, sometimes it's manual, sometimes it's completely disconnected, right? So our job, our mission, and all of us is how can you formulate an IoT or a digital transformation strategy that you see at the bottom there that is really focused on 4 pillars. And I like to start from the right, number 4, and actually count backwards, starting with the return on investment, right? We strongly advise always taking an ROI-based approach and identifying what is the problem that I'm trying to solve, and then going backwards to identify what's the connectivity status, right? Am I collecting data to solve that specific issue? For example, if I'm looking at maximizing the uptime in my operation, or reducing scrap or quality issues in my operation, or optimizing my spare parts in inventory, what is the problem definition? What is the metric behind it that I'm trying to track and improve? And then, am I connected? Number 3, am I receiving data to support the business case that I'm trying to form? And if I'm not connected, how can I collect that data? We're going to talk about that today. And then number 2, your analytics, okay? So I like to talk about 2 types of analytics. Performance analytics, which is an understanding of how you're performing today and how you have performed historically. So there are metrics to do that. And predictive analytics, which is an understanding of the future behavior of your process and your assets. When are they going to fail before they actually fail? And the concept of moving or transforming your operation from a reactive, time-based operation to a predictive and prescriptive operation. And then number 1, technology. I'll talk about this at the end, right? How can you think big and start small and prove value fast in a controlled, more confined environment? For example, you would select one factory, one line, one lab, one machine, right? You prove it. Hopefully you succeed fast, get the ROI, and then talk about technology scalability, right? How can you scale that template across similar assets, similar plants, or a variety of other types of areas in your manufacturing floor? So a lot of content here, but it's very important to understand what is IoT, what is industrial IoT as a subset of IoT, Industry 4.0 being the initiative that is driving industrial IoT adoption today in industries and manufacturing. That's the orange bubble you see right there. And then at the bottom of that, the 4-pillar strategy that you should consider in any IoT project that you're embarking on today. So moving forward, I didn't touch on in the Industry 4.0 yet, so I've included a slide to introduce that concept. Industry 4.0 is named the fourth industrial revolution. Okay, this is actually a German-born initiative out of Germany. It was architected by some government organizations in Germany, including the Fraunhofer Institute, and it has spread like wildfire around the world. It was adopted by the EU, and it was adopted by the National Association of Manufacturers, NAM, in the United States, North America. And in the US, in manufacturing, sometimes we refer to it as Manufacturing 4.0. And in some cases, it is adopted as a smart factory strategy or a smart product strategy. Okay. But I'm going to summarize Industry 4.0 in a very simple definition that you see at the top of the screen there. It is combining traditional practices of manufacturing today with technological tools, okay? Tools like smart machines, human-machine collaboration, AI, predictive analytics, and we'll be discussing some of those tools today, okay? But the fourth industrial revolution is meant to help provide a digital connected society in manufacturing. And there's an interesting concept that is a key part of Industry 4.0, which is called CPS, a cyber physical system. Okay, if you look at a factory operation today, it consists of physical assets, right? So that's your physical. And then if we look at the IT world, your cyber world, if you're able to mirror, simulate, collect data, track it for those physical assets in the cyber IT world, that is a cyber physical system. And sometimes it's referred to as a digital twin, right? So those Industry 4.0 tools that we will discuss today are able to support creating a cyber physical system or a digital twin of your physical operation, whether that is a manufacturing facility or a lab or some other type of process that you're trying to establish an IoT strategy for. So why is implementation accelerating? Many reasons. Obviously, supply chains are becoming more complex. The volume levels and the mix levels of manufacturers is quite different. You might have a factory that has a high volume operation like making automotive parts. You might have a factory that is a low volume, high mix operation like making parts for a jet engine. You're making a part every few hours or few days. Cycle times are very long. Versus in an automotive facility, you're making parts every few seconds, right? And sometimes in milliseconds in the electronics industry. So it's important to understand that there are opportunities, there are challenges, and if we're able to understand within a plant or within a lab or within whatever setting you're trying to apply IoT, what are those challenges and countermeasures, and which tools of the digital tools of the trade make most sense to your operation, there will surely be a revenue generation behind it and a basic win for your operation. So think which of these issues today may be an issue for your operation, right? And think of ways to address them using an IoT or a digital transformation strategy and what tools make sense. I'm going to summarize the challenges in a very simple slide, actually, because it all revolves around the right side of the screen here, people, process, and technology, okay? At the end of the day, adopting and implementing an IoT strategy in any operation, it's important to understand what's the weak link, right? And one of those three is usually the weakest link. And being able to address that weakest link and have countermeasures behind it will surely support generating a very strong win and a very strong ROI for any IoT type of deployment. So if you look at the right, and maybe we pick technology first, if you look at what we call the top floor, that's your IT systems, okay? Again, many companies, if you remember that automation pyramid, maybe they're lacking a piece of that pyramid. They don't have an execution system. Their ERP system may be outdated. There needs to be upgrades there, right? So legacy IT systems are a challenge when it comes to technology, because it is difficult in many cases to integrate with those systems and collect data from those systems and send data back to those systems. And then if you look at the shop floor layer, the plant floor layer, that's your legacy equipment. So in the same manner, you have old machines, right? And sorry, I moved forward too quick, but those old machines are sometimes referred to as dumb equipment. They are dumb, but they're very capable. Okay, they're making parts. They've been around for 40, 50 years, making parts, making good parts. So how can we extract data from legacy equipment that have outdated drivers? They don't have Ethernet ports. Maybe they have a serial port. Maybe they have a relay logic, right? How can you extract data from old pieces of equipment? And the answer is, it is possible. And I'll talk about an example. And then going into people, right? We do some work in aerospace, and sometimes I ask in an aerospace company, like an aerospace OEM making jet engines, right? Guess the average age of a machine operator in an aerospace OEM like a GE Aviation or a Pratt & Whitney. You'll be surprised with the answer. The average age is actually 55 years old, okay? So you have aging workforce that has a lot of good knowledge, in many cases tribal knowledge, that is not documented, and they're graduating soon, they're retiring soon. So how can you fill that gap, right? How can you enable new generation of workforce, A, to be interested to run CNC machines, for example, and B, to kind of get that knowledge of that retiring aging workforce that allows them to use those machines and to use additional digital technologies to support their IoT initiative. So workforce, education, apprenticeship, training is really key to success when deploying a digital solution, and an agenda and a plan must be put in place. There comes processes, right? You're putting new processes, you're collecting new data. You have HMIs, human machine interfaces, where you expect operators, some older, some younger, to use those interfaces to see machine data and input information into those systems to drive their IoT strategy. So how can we create those HMIs, those human machine interfaces, in a collaborative way to allow operators and users to use solutions intuitively to drive value for their business, right? Sometimes we say it's important that IoT solutions are role-based. You need to have the right information for the right role at the right time. Otherwise, you end up with a situation of data analysis paralysis. You're overwhelmed with data and you're unable to act and make actionable decisions, right? So that's all part of process. And now that we've understood some of the challenges around people, technology, process, of course, at the end of the day, and I kind of put it at the lower priority here, funding. People, process, technology leads to profits at the end of the day. And if we make this recipe of people, process, technology strategically in the right manner, it will surely alleviate any issues around funding and access to capital, because it would truly be driving ROI for the business. So I'm going to go to the next slide using my special app here. The business case. So I'm going to summarize the business case with a simple slide, actually. Please identify your metrics. Your metrics may be different from what I'm showing here, but if we look in a factory operation today, there is a metric called OEE, which is a key metric to the operation. It stands for overall equipment effectiveness. And I'm a believer that this metric can be even applied in a lab or any other type of process, because it consists of three things. One, availability. What is the uptime? What is the utilization of that factory or that process? Second, performance. How fast or how efficient are you actually running your process compared to the standard, right? What is your plan versus actual? If I'm supposed to make a part in 10 minutes, and I've made it in 5 minutes or I'm making it in 20 minutes, there's an efficiency factor there. And it's important to understand the deviation, right? So that's performance. And number 3 is quality, right? What is my scrap rates and what is my rework rates? What is my yield? And what are other factors impacting quality? What are the quality characteristics that I'm collecting? And what is the root cause, basically, of creating a scrap or a defective part in my operation? And then if we look at the actual gains today of clients, and these are real numbers surveyed from some of our clients using digital solutions, you're seeing 5 to 20% jumps in the OEE metric over a period of usually 3 to 6 months. And a lot of it comes from an interesting psychological effect called the Hawthorne effect. The Hawthorne effect is all about if I'm seeing how I'm performing, right? If I have a visual aid and I can see what I'm doing in real time, I'm able to act in real time and I'm able to behave differently, right? So there's psychology and a psychology element to it, but there is, of course, the improvement element to it, because now you have real-time data. You're using the data as part of your lean organization, your continuous improvement organization, and you're making timely decisions in real time to make those improvements. And then, of course, 15 to 25% labor productivity gains, right? Moving away from a paper-based environment to a paperless environment surely allows operators and labor to behave more productively, right? With real-time information coming from the assets and coming from the sensors, helping them drive their daily work. And then if we look at one of the tools like predictive maintenance and using artificial and intelligence and machine learning algorithms to improve maintenance activities and transform from a reactive to a predictive paradigm of operation, we're obviously reducing unplanned downtime, okay? I mean, at companies like Toyota, they're running lines very efficiently. I'm talking 95% OEE. The lines are running, making cars, but a 1 minute of unplanned downtime on a Toyota line or any automotive line actually could be near $10,000 per minute of downtime. And those are real numbers from the automotive industry. So this is a mission critical line. It's an uptime critical line. And the business case there is, how can I use analytics and sustain a very high level of uptime on that line? And I can only do so if I'm collecting data and I'm applying analytics on that data to support me to predict future behavior and sustain those high levels of uptime in my operation. And then lastly, there's an interesting link to spare parts and labor time. A lot of manufacturers today and a lot of other operations, they're keeping high levels of spare part inventory because, simply speaking, they're waiting for machines to fail in order to fix them, right? And in some machines, spare parts are more difficult to get than others due to the age of the machines, and the spare part availability is not there. So by using predictive insights and AI as part of your IoT strategy, you're able to make, in many cases, accurate predictions of when the machine is going to fail before it actually fails. And that would allow the manufacturer to link to their spare part system and even order a spare part for a machine before the machine actually fails, with a lead time of, say, a few days or a few weeks in some cases. And therefore, reducing spare part inventory by using predictive insights can actually be a huge ROI and reduction in overhead costs for any manufacturer or any company today. That also goes to the PM schedules. If I have a better understanding of future behavior and failure on my machines, I'm able to reduce preventive maintenance schedules, or I'm able to optimize my preventive maintenance schedules so I can send the right person at the right time to fix the right area of the machine, rather than having to go and every 2 weeks, I got to go and change my robotic. I got to change all my bearings, right? Now I can tell you, the axis number 3 on the bearing of the robot, number X, is going to fail in the next 10 days. Please assign Joe Smith. He's going to go and he's going to fix that machine on time, and your spare part is going to arrive on time, right? So things to think about, okay? What is the business case that is driving your operation today? What is the metric by which you measure success of an IoT solution? Think ROI first and make that drive your technology adoption. So that brings me to the technology adoption and the digital tools of the trade. Once we understand ROI, we identify our success criteria, we're able now to go in and talk about, am I connected? Do I have the right data? What are the metrics by which that data can help me optimize? And then what are tools like AI and predictive analytics to support my journey? I want to define a term which is very important, and I refer to it, or we refer to it, as digital maturity. Okay, different plants, different organizations, even the same factory may have different departments and areas that have different levels of digital maturity. In other words, the people, process, technology components vary from plant to plant and department to department. Okay. In some cases, I'm at the lower end of the digital maturity. I would say step number one there. Okay. I may be connected. I may not be connected. I'm using paper. I don't have real-time data. We call that a level 1 of digital maturity, or even a level 2, depending on things. And in some cases where you have data, you've adopted metrics like OEE, which is number 2 there. You're doing some execution, which is number 3, for example, quality, SPC, traceability. That brings you up that digital curve, right? The use of digital tools and the harmonization of your people, process, technology element of your strategy allow you to start climbing that ladder of digital transformation. And in some cases, some manufacturers and non-manufacturers are quite mature. They're collecting data, they have metrics, they have execution, and they have even data scientists on staff that are using AI and machine learning to make improvements in their operation, right? So at IoTco, and there are other institutes out there that define a digital maturity index, a DMI, and it's important to understand what is your index today, what is your level of maturity, because that really dictates the phased approach upon which you will embark on your digital transformation, and of course how long it's going to take and how much it's going to take of effort, right? So I'm going to show a hint on each one of those numbers here, primarily 1, 2, 3, and 4. Okay. And what I'm doing today is part of our academy anyways. The slides I'm going to show are part of the training courses that we provide to industry, and also the training courses where we collaborate with educational institutions like the University of Cincinnati. Here we're doing an Industry 4.0 course, which is a master's level course as a prerequisite to an engineering program, which can also become an industry certificate. So let's start with connectivity. Okay, are you connected? And I'm gonna keep this very simple and say manufacturing data, or data in general, and I would maybe missing a word there right before data. Real-time data is the foundation to achieve any ROI whatsoever from any continuous improvement effort. Okay. And those are questions that we usually ask during a discovery. And they are questions that you can ask yourself, okay? Whether you're in a manufacturing plant, or whether you're even in a non-manufacturing area. Is your asset capable of communicating, okay? And it's important to understand that there are new machines and there are legacy machines. And there are ways to capture data from both types of assets. Second is, if my machine is not capable, what type of gateway device, what is the IoT gateway or hardware unit that I can procure off the shelf? How much does it cost, and how rugged it is for my operation? And how can I connect it to that machine to capture the data I'm looking for? Number 3, how long is it going to take me to get connected? Obviously, with newer types of assets, there are drivers and protocols that allow it to talk to the outside world. One of those protocols is called OPC. OPC UA is a known protocol with the OPC Foundation that enables different types of machines to talk the same language. And if you have CNC machines on the factory floor, like machine tools, there's a language called MT Connect that is also a common language to speak. There are sensors out there. You may be using IFM sensors, for example, that speak languages also. There's a language called IO Link. It is a protocol that is used by sensors to also speak to the outside world, right? So what is the language of that asset? What language can it talk to the outside world? And how am I going to do it? How long is it going to take? And then number 4 and 5 there, how much data is available and what type of data do I need to capture, right? I mean, some assets can give you hundreds of tags, hundreds of signals. But what do I really need to fulfill my use case, right? If I'm looking at a simple machine with just wanting to measure uptime, right? I need 5 or 6 basic pieces of data. I need my uptime. I need my cycle start. I need a piece counter. I need my feed rate of my machine, right? There are 5 or 6 basic signals. But if I'm looking to do process monitoring and traceability of my part, and if I'm looking at doing predictive maintenance on a spindle bearing of a CNC machine, I'm looking for more, right? I'm looking for vibration data of an accelerometer. I'm looking for a current signal, a temperature signal, maybe the program ID that is running on the machine, right? So it's important, again, to understand what's the ROI, what's the problem definition, what's the use case, and then that dictates the type of data and the type of signals, what I call the data map there on the arrow, machine data map, that is documented and that allows you then to take that data out of that asset or of that sensor or the machine and then make that data available, okay? So let's talk about how can we make that data available. There's a lot of systems out there, okay? There are historians, there are SCADA systems, and it really depends on what you're trying to achieve, okay? It depends on the volume of the data, the variety of the data. You know, if you have a factory with all types of different controls, right? I have my Allen Bradleys, I have my Siemens, I have my Makino machines, right? That's a huge variety of asset types. And there are some data collection systems out there that would provide you better insights. Okay, for example, Kepware noted there is an OPC historian that supports over 100 different drivers. Okay, so if you have such a variety of assets on your factory floor, a solution like Kepware OPC may be useful for your operation, right? It's an off-the-shelf tool. But if you're more focused on process data and maybe data acquisition, a SCADA solution like Ignition or iFix may be more useful for your operation. So the message here is if you want to get connected or if you want to improve the connectivity, which is a key part, is the foundation of your IoT strategy, think of what is my data source that I need to capture data from? What are the data types that I need to capture, right? Do a discovery, do an audit, what we call a connectivity readiness or a connectivity audit, and then make the right decision on the type of data collection tool that makes sense for your operation. And then think of the interoperability of that tool, okay? So can this tool, can my Kepware or my Ignition or whatever you select, can it talk to third-party systems in a proper way? Can it talk to my maintenance system? Can it talk to my predictive system because I want to do AI on the data? Can it talk to my execution system, right? So we call that interoperability. And in the new world, you know, nowadays, these solutions are becoming more and more complementary to each other. They have APIs and application interfaces that allow them to talk readily to other IT systems, which is very important so that you can send data to the right place. So now that I'm connected, what do I do with the data? What metrics are meaningful for my operation, right? Everybody measures productivity, but truly speaking, productivity is the tip of the iceberg, right? Underneath productivity, underneath the waters, you know, there's a hidden factory, there's a hidden operation. There are underlying metrics that must be measured and tracked in real time to truly understand what is the root cause of my productivity gains or my productivity losses in the manufacturing operation. And we call them digital metrics. Those digital metrics can truly help you and any operation unleash the hidden factory, okay? It is truly a hidden operation. And it only comes with getting connected and then using that data to create those true digital metrics like OEE, availability, how long has the machine been running, performance, how fast the machine is running, quality, how good the machine is running, right? How good the parts are being produced. And then that's your OEE metric. That's a surface level understanding of what is leading to productivity gains or losses. But yet the machines still fail, right? Machines still go down due to unplanned reasons, and it impacts your OEE. So think about going a level deeper. Think about understanding what is the health of the machine, okay? Maybe my machine is running at a high level of efficiency, but yet the machine fails. So I would need an understanding of what is the health of the machine to continue running at a high level of availability. What is the RUL, we call it, the remaining useful life? How much prediction window do I have until the spindle bearing on my machine tool fails, or until my pump or motor fails? And my pump and motor, they're controlling my line. And if they fail, it is a high severity. It is catastrophic to my line. The line is going to stop, right? So what is the prediction window there? And of course, what is the prediction accuracy? Any prediction comes with an accuracy. And then lastly, what is a diagnosis? If we are predicting that axis number 3 on a robotic is going to fail in the next 10 days, what is the reason? Is it a gearbox backlash on my motor? Is it my bearing have a temperature spiking? Have I changed something on the robot program that is now, causing me to fail faster than usual, right? So diagnosis is all about the root cause analysis of the true reason of that failure. So now that I have my metrics, how can I visualize? How can I represent those metrics to the right person at the right time so that she or he can do their job better, right? They can have actionable insights. And it's important to understand that new technologies out there are not just real time, but they're integrated. They allow you to integrate data from the factory floor to the top floor. They are accessible. They are mobile, okay? Gone are the days of having to install the software and log in and, try to import data and all that. Those solutions now are accessible via a browser. Open up a browser, access the right system on your network. You can log in. It's HTML5 based solutions. You can see them live, right? And this is just an example. They are configurable. Here is an operator sitting next to a machine, for example, that is visualizing what is my OEE in real time and what is my plan versus actual. How many pieces am I producing based on the target, right? And it might be easier shown than done, right? Because to do this, you need real-time connectivity to the assets. You need data flowing from your ERP system. And you need, obviously, a validation to make sure that the operator is comfortable and trained, right? People, process, technology, comfortable and trained to use the solution on a daily, an hourly, or even a minute-by-minute basis as they are running their machine, right? So think about how you can visualize your metrics to the right person at the right time to drive your business forward. And then think about growing it, right? Connectivity and metrics will lead to execution. And, there is an organization out there called MESA, M-E-S-A. They partner with ISA regarding the ISA 95 standard. And they define 4 areas of execution for any company out there, okay? And this one is more focused on manufacturing. But we talked about OEE, which is part of production, okay? OEE and job tracking and downtime tracking and scrap tracking, right? But there's also your inventory, the traceability of your parts, right? We talk about the birth certificate of a part. You're making parts, your parts are coded, especially if they are safety critical in aerospace or automotive, right? How can you trace that part? How can you ensure there are no warranty claims, no recalls on that part? To do so, you have to be able to be connected and you have to be able to trace that part from the raw material all the way until the end product when that part becomes part of your car or part of the jet engine on a plane, right? So traceability is key and product genealogy is key using IoT and using connectivity to reduce warranty and recall issues, especially with safety critical parts. And then we talk about quality, and I'm sure in your worlds, quality is key. Quality checks, statistical process control. But I'm not talking about doing it manually. I'm talking about, or I'm not talking about using an offline Minitab solution to do my quality tracking. I'm talking about real-time data collection from the CMM machine, real-time data collection from your gauges, your quality inspection units, your vision cameras, right? And by getting that real-time quality data, real-time quality attributes and features, you can bring that data into a real-time SPC solution, right? That is able to look at that data and provide you your gauge information, your CP, CPK, process capability type of information. Again, in real time to drive actionable decisions, right? And then there are other things around maintenance, of course, and I'll talk in more detail about predictive maintenance here on the next slide. But it's also important to have a maintenance foundation, to have a maintenance system in place, to have a TPM procedure, a total productivity maintenance system in procedure, because you need somewhere to organize your master data, to organize your spare parts, to organize your preventive maintenance schedules and your maintenance labor, right? And those are usually part of a maintenance system, so that when you embark on that digital journey and you use AI and predictive analytics, you're able to close the loop and send that information to a maintenance system that can do something with it, right? That can make real-time decisions regarding maintenance scheduling, maintenance labor, and maintenance spare parts. So we'll close with predictive analytics as kind of that final digital tool of the trade. And predictive analytics, very simply speaking, is about capturing data from a data lake, bringing that data into an industrial AI solution, and then doing something with that data, your use case, okay? And, in this presentation, I'm focusing really on two use cases. One is predictive maintenance, which is focusing on the asset itself and the future behavior and failure of that asset, whether it's a robot or a pump or whatever you might have as a critical asset. And we also talk about predictive and prescriptive quality. There are some areas where scrap rates are high. And a good example in my world, in the automotive world, is casting machines, high pressure die casting. I mean, the industry norm for a casting machine is like a 9 to 10% scrap rate. So just imagine, it is normal in industry today on a casting machine to make 10% bad parts, okay? That's industry norm. So how can you use artificial intelligence and machine learning to detect and predict scrap issues and defect issues on a casting machine and make prescriptive decisions? So if I feel that, or if I'm predicting that my casting machine is making a bad part, my AI commands the machine to automatically reject that part. So we call that auto part segregation, right? If you make a bad part and the part goes to the next value stream, it goes to machining, or it slips out and goes to the customer, you got a warranty, you got a recall problem, right? So how can we use artificial intelligence and machine learning not only to predict machine issues, but to look at correlations in the machine and the quality data and predict defects on the machine, on the part as well? So we talk about a 6-step, very systematic process to do that, okay? We talk about you need to get connected, get the right data. We talk about machine learning, which are a set of algorithms that are part of artificial intelligence and AI that help you process the data, signal processing, removing outliers, cleansing, basically preparing the data for the machine learning process. And then we talk about feature extraction, which is the statistical indicators or metrics that are derived from the raw data, okay? And they could be time domain features, frequency domain features, wavelet features for any of the data scientists who may be on the call. And then we talk about health assessment, right? I want to build and configure a health assessment model that allows me to understand the baseline of the machine. Sometimes we call it a fingerprint. This is your fingerprint or signature of your behavior today. And this is the drift away from that baseline, right? So it's a multivariate approach to take those features, train a health assessment model that understands what is your behavior today, And then number 5 starts to predict your behavior in the future. And of course, you need training data for that. You need baseline data. And we typically need at least 2 to 4 weeks of data to build a statistically confident model that is able to be used for prediction, okay? And then diagnosis. If I'm predicting a failure, which component of the machine may fail? And in addition to that, which process parameter? Is it the temperature signal? Is it my pressure signal that is leading to that failure? So here is just important to understand that this is not a one-size-fits-all, okay? There are templates out there, and the templates, from our perspective, really depend on the type of asset and the type of process you have on the factory floor. You know, if anyone is interested, get in touch with me. If you have robotics, CNC machine tools, casting, injection molding, stamping, or maybe in your laboratory environment, there are ancillary equipment, right? There are pumps and motors and gearboxes and valves that may fail, and those failures are, you know, uptime critical or quality critical to your operation. So this is not a one-size-fits-all, but however, it's important to come up with the idea of solution templates, because the field of AI and machine learning is not new. It's been around for decades. There is a lot of proven methodologies and algorithms out there that have been applied already to 25 plus different solution templates. And I'm just showing you some examples here. So the message here is these solutions should be deployed quickly within weeks, and they should not become data science projects that run for 6 to 12 months, because that becomes a lengthy project, and lengthy projects obviously are over costly for the business, okay?
Yep. You're welcome.
Here's a very quick example for industrial robots. The message here is, you know, AI and machine learning is not magic, okay? It can help you do something, but it also has drawbacks. For example, we cannot capture a cable failure on the robot, right? That's a preventive maintenance schedule that you have to put in place. But it can help you capture that you have a worn belt, or if you have a motor brake failure, or if you have a gear backlash, right? So always think, what are those failure modes that you're going after? And then how the solution can help you address those specific failure modes that are impacting your business. The message on this slide is the end user, right? Going back to people process technology. If we talk about people, the end user is usually a maintenance manager or a maintenance technician, right? In a factory or in some operation. So we should not expect them to be a PhD or a data scientist, right? They are maintenance engineers. So it's important to build and configure human-machine interfaces that are operator-centric, right? User-centric. They should be intuitive to be used by folks that do not require the need of being a data scientist, right? So if I'm a maintenance manager and I'm looking at a dashboard like this, I could immediately grasp that my health has degraded over time. There's degradation on my machine. I could immediately see a prediction, remaining useful life window with a prediction accuracy, of course. I can receive predictive alerts by text, by email, to be able to act. This solution could even connect to my preventive maintenance system if I have SAP PM or IBM Maximo, whatever that might be, right? And request a spare part, or tell me that I need to do maintenance tomorrow, and John Smith needs to be assigned to do the maintenance. And lastly, at the bottom there, it should give me a diagnosis. It should tell me which part of the machine is going to fail, because I don't want to go and fix the whole machine. I want to fix the right part of the machine for the business case I'm after, right? So think of intuitive ways to realize the data for the end user. Two quick examples I'm going to conclude with. Predictive maintenance and predictive quality. It's all about ROI, kind of circling back to the beginning of the presentation. Pilot ROIs for these solutions should be about 3 to 6 months. If you feel you're not getting an ROI in a pilot within 3 to 6 months, something is not right, and you should pivot. You should do a lessons learned. You should immediately understand, where's my issue? Is it people, process, technology? Make countermeasures and move forward. Please do not try to extend pilots beyond their means. I've seen many folks who say, 3 months, let's give it another 3. Let's give it another 6. Don't do that. because something's wrong, it needs to be assessed, and you need to recalibrate. Predictive quality, if you're reducing scrap in a factory, I mentioned the casting example. Just imagine 1% scrap reduction. We call it the power of 1% in a casting operation in an automotive supplier is at least 250K per plant per year in savings. Okay. So think, what is your ROI from doing IoT and predictive analytics today? And you can follow National Association of Manufacturers. They have started an AI Leadership Award last year. One of our clients won it last year. We have another client that won it this year. But it's quite a prestigious award, and it's a good committee of intellectuals like you and me who come together once a year and really talk about things in more detail. So I'm going to conclude with a call to action and start taking some questions for the last minutes. Very simple. Just please read the top of the slide. Think big. That's good to always do that. But start small. Select the right place to pilot those solutions, prove value, and scale fast. But also, don't be scared to fail fast, okay? Failing fast in 3 months is better than running pilots for 6 to 12 months and hoping for results, right? So it's good to fail fast and to pivot and to find right ways to do it. We talk about a 3-step process: discover, design, deliver, 3Ds. And we talk about a 1, 2, 3 process. Assess usually takes a day if you're very focused. We talk about doing a workshop. Usually takes 2 days to go a bit deeper into the needs. And then we talk about a proof of value, a POV. That is a pilot with a business case and a value attributed to that pilot, okay? So these are not proofs of concepts. They are proofs of values with an ROI to be generated from the proof of value. And it should be deployed within about 3 months. It should run for 3 months. And then after this, you should discuss the scalability, the training, the people, process, technology behind it, and a concept we call center of excellence, right? A multidisciplinary team who can take your IoT strategy and maybe autonomously start scaling it within the operation. Last but not least, please consider starting today if you haven't, okay? Make your strategy operational with a proof of value. And I'm going to read this because it's really key, right? A proof of value is a fundamental business transition. It aligns the technology you've selected with a business plan and a business objective and an ROI metric. So business meets technology, delivers you a proof of value for your operation. And whether you run factories or whether you have products that you sensorize, and I didn't talk about this today, but the analytics and the templates and the AI and the tools are actually quite similar, maybe the same in some situations. But the end user experience is obviously different, right? In a factory, I'm working towards what we call a zero downtime, zero defect vision of my operation. In a smart connected product, I'm using analytics to drive new business models, new service lines to my customers to improve their customer satisfaction and customer retention. And last but not least, my advice always remains, improve your weak link, people, process, or technology, because your benefits in a pilot or your benefits in a scalability of an IoT solution is really as far as your weakest link, right? So you should find the right place to start with the right people, the right process, and the right technology. And that would be your showcase, that would be your lighthouse, I would say, for the scalability of your IoT solution. So again, I appreciate the invitation by PEI. Thank you, Stuart. Thank you to the team. Thank you, everybody. Thank you for your attention. I'm happy to be here for another 10 minutes to answer questions with you. And back to you, Stuart.
Yeah, thank you very much. We appreciate you having us. We got a couple of questions here for you. So one from Mike Duke here. Key enablers for data analysis are connectivity and traceability, but they don't create savings on their own. Have you seen business cases justifying these?
So the question is, have I seen business cases justifying it, right?
Yes.
So the answer is absolutely. I mean, at the end of the day, there has to be a team that is driving the technology adoption, usage, and and basically driving the ROI. It's usually a multidisciplinary team. I have seen major business case justifications in both areas. I mean, connectivity is really the foundation for everything. The data you're capturing in real time from the factory floor that is being used by people and IT systems is key to the success of any continuous improvement effort. And a good example on traceability, you know, for automotive, for example, if you have part traceability and you're able to detect failures before they leave the factory, or if there is a recall issue, you have a traceability, you know, electronic solution in place. I mean, I have seen major mitigations of recall costs, very costly recall costs, and possibly reputation hits from both automotive and aerospace clients, at least, by using real-time traceability solutions. So the business cases are absolutely justified, but of course, I mean, they don't create savings on their own. They need people that are trained and processes behind them that are able to help generate those business cases.
Very good. We got a couple more. Does all data need to be collected in real time, or can historic data also be collected and used?
I mean, surely data will be collected in real time from assets and PLCs and sensors and all that. That's quote unquote your data lake. And that data lake becomes your historic data. But of course, if you're not collecting real-time data today and you have some historic data that may be manually generated, as long as you feel that data has integrity and no errors, no mistakes, human issues into it, surely that historical data can be used to create baselines. But our view of the world is real-time data drives high-quality decisions in any operation.
Yeah, I can hear you. Yeah.
How do you handle and what advice do you give to manufacturers that have data security concerns?
Yeah, that's a good question. Cybersecurity is surely a key challenge that I did not address in my presentation today. With the use of cloud platforms nowadays, Microsoft Azure's and AWS and all that, a lot of those platforms are coming with many built-in security approaches. Some manufacturers or operations still go with on-premise more secure solutions where they are not using the cloud. I mean, my general advice is to have a cybersecurity strategy in place and to have a cybersecurity advisor or a cybersecurity third party that is working with you to do an assessment to address the gaps, to document those gaps, whether you have a cloud strategy or whether you do on-premise IT, approach. So my advice is simply find the right advisor or cybersecurity organization that would do an assessment with you and would help you understand your gaps.
All right. Looks like we got one more and just came in. It says, what about cleaning data? How careful do you need to be to not miss an outlier that may be something real, a process further out of control than you think?
Yeah, that's a good question. It's important to have good baseline data for any model or any AI, any ML algorithm. And it's also important to understand the repeatability of that data. So that's why usually we would not pilot, for example, an AI ML solution on one machine. We will pilot it on 2 or 3, 4 similar assets. And we would have data from similar assets to compare to each other and to make sure there is integrity of the data, whether it's coming from the machine or whether it's coming from sensors. And once we feel that the data source has high integrity, high quality data, we're able then to find the right signal processing type of algorithm to make sure that we're not removing data or removing outliers that are not actually outliers. So this is where we would still need expert domain knowledge. There should be somebody from the organization who, say, understands the CNC machine, understands the spindle or the vibration data from the machine, and is able to give expert guidance, right? So these solutions are surely not magic. There are mathematics behind it, statistics behind it, but there's still expert knowledge that should be incorporated when deploying these solutions today?
Well, very good. We did get a few more questions, but I do know that you have to run, so I will compile these and I can send them over to you in an email and we can get them answered for these guys. I want to say thanks again for joining us. We really do appreciate you coming. Thank you for being flexible with your time and working with us in this virtual format. So that was great. We appreciate it.
Thanks for the opportunity, Stuart. Thanks to the PEI. Have a good day.